Okay, so let's look at this problem here. So we're dealing with forces now, and what we know is that a force has both magnitude and direction, so it's a vector. We also know acceleration is a vector, so it has direction as well as magnitude. Mass is a scalar value, so it doesn't have any direction. We also know about velocity, which is a vector that does have direction. Displacement also has a direction, so is a vector. So we're going to apply our knowledge of forces and suvat when we're using constant acceleration, as well as what we know about vectors from our pure maths, to be able to solve problems in 2 dimensions. Okay, so probably the best way to do it is to just do the example, and then hopefully you'll see what we mean. So we've got a constant force, F newtons, F is a vector, acts on a particle of mass 2 kilograms, scalar value, for 10 seconds. Time is also a scalar value. Particle is initially at rest, and 10 seconds later it has a velocity of 10I minus 24J. So we can write our vectors in that form. We can also write them in that form. I think for the sake of these questions, I'm going to use this notation. I just find it's often quite kind of easier to be able to see what's going on. Okay, so let's have a think about how we're going to do this. So I am given a velocity. I'm told that it was at rest. 10 seconds later, that was the velocity. I'm given the mass of the particle. I'm being asked to find F. So I've got the mass, I'm asked to find F, so I'm going to have to find the acceleration. So to find the acceleration, I'm going to use suvat. So let's see what happens. I'm going to use suvat, but I'm going to be applying suvat to vectors. So I'm told that the particle was initially at rest. So my u is 0. So it's 0 in the horizontal direction, it is 0 in the vertical direction. So I'm going to write it like that. I could write 0I plus 0j, but I'm going to write it in that notation. Okay. I'm told 10 seconds later the particle had a velocity of that. So that will define the magnitude of it as well as the direction in 2 dimensions. And I'm being asked to find A. So what I need to know is what the horizontal component of A is and what the vertical component is. It will be accelerating in 2 directions, if you like, which is going to give us a vector. So I'm going to call that AB, because I want to know the horizontal component of the acceleration and the vertical component of the acceleration. Okay, so as if this was just values rather than vectors, we can just apply suvat to it. So I know V equals U plus AT. So V is 10 minus 24. U is 0, 0. A is AB and T is 10. So I'm just going to write 10, so that's T times A. Okay, now we can just apply our rules of vectors here. Now we can always multiply a vector by a scalar, can't we? So actually what I have here, what this resolves to, so that doesn't apply, 10a, 10b. If I multiply a vector by a scalar, I just multiply both parts. So actually, can we now see that 10 equals 10a? I can just equate the horizontal components. So a equals 1. And minus 24 equals 10b. So b equals minus 2.4. So the acceleration is 1, negative 2.4. And if we wrote that in the ij format, that would be I minus 2.4 j. Okay, so we now have the acceleration. I'm being asked to find f. So I'm going to say that f equals mass. So I'm told the mass of my object times acceleration. Again, mass is a scalar, acceleration is a vector. So I can just multiply through. So the force is 2 minus 4.8. As I got the question in that notation, I'm going to leave the answer in that notation. 2i minus 4.8 j.